The Schrodinger Impact Basin is located on the lunar far side near the South Pole and is named after Erwin Schrödinger, an Austrian physicist and Nobel laureate. It is the second youngest and least modified multi-ring impact basin on the lunar surface. It has a diameter of 194 miles and contains a peak ring structure that was formed when the impact forced crustal materials into a circular ridge just under 100 miles in diameter. Switching to the Chang'e 2 CCD orthomosaic and continuing our descent. The Schrödinger G pyroclastic vent is a fascinating site with huge potential for future exploration of the Moon. It is a large cone-shaped volcanic vent that shows signs of eruptions that occurred 500 million years ago that can be seen as darker pyroclastic material around the crater, and is also located on an east-west trending graben where lava once flowed. It rises about 1,360 feet above the basin floor, and whose lower reaches are in permanent shadow. Permanently shadowed regions may contain frozen volatiles, possibly water ice, which would be valuable by using local materials to support exploration activities. Using the narrow-angle camera layer from the Lunar Reconnaissance Orbiter, more of the crater interior is revealed to show outcroppings and landslides, as well as a small impact crater. Notice this cluster of craters on the edge of the pyroclastic cone. Seen here in this image from the Lunar Reconnaissance Orbiter, these craters are a region of interest, and although they are relatively young, the craters in this cluster have a subdued, worn appearance because they formed in the loose pyroclastic material. Schrödinger is a scientifically rich exploration site with bedrock exposures and uplifted deep crust for crystalline lithologies, floor fractures, mare volcanism, and immense pyroclastic deposits for thermal and volcanic evolution studies of a planetary body. Just to the north of Schrödinger are two long, linear valleys designated Schrödinger Valley and Planck Valley. They are oriented radially to the Schrödinger Basin and were most likely formed by that impact. Using the Lola color data layer, laser altimetry enhances the surface features and the valleys become more apparent. Valles Schrödinger begins at the outer rampart of ejecta surrounding Schrödinger and continues to the north-northwest until it crosses the rim of the crater Moulton. About midway along its length, it crosses the crater Sikorsky and is overlaid in turn by the small satellite crater Sikorsky Q. Valles Planck has a length of 312 miles. It is named after Planck Crater, even though it is oriented radially to Schrödinger. The southern edge, located closest to Schrödinger, begins near crater Grotrian, then continues to the north-northwest, where it is disrupted as it crosses the crater Fechner. The valley continues to the northwestern outer rim of Planck, until terminating here near Pickelner K. This widest section of Valles Planck has a width of just under 18 miles. Using an elevation profile, the depth is calculated at 9,911 feet or 3,021 meters. Planck Crater, named after German physicist and Nobel laureate Max Planck, is a walled plain approximately 198 miles in diameter and formed over 4 billion years ago. On the southeastern rim is Planck Crater. This crater is roughly circular, but with an outward bulge to the south-southeast. The rim is worn, but still retains a well-defined edge. Several small craterlets lie along the rim and inner wall, the most notable being a pair of small craters along the eastern side and a small eroded crater intruding slightly along the south. The interior floor is generally level, with only a small rise to the south of the midpoint. There is a cluster of 3 small craterlets along the southern inner wall. We now zoom down to the northern section of Planck, which contains a multi-crater formation. This formation consists of Planck W, Planck Y, Planck Z, Planck B, and Planck A. The interior of Planck Y has been almost completely flooded by lava, leaving only a shallow perimeter. Likewise, Planck Z has been flooded, although its rim is somewhat more prominent. This small crater that interrupts the floor fracture has a depth of 341 feet, 104 meters, and has a diameter of 2.8 miles, or 4.5 kilometers. The interior of Planck B is partly occupied by a concentric crater, and the floor contains several clefts. Planck A has a diameter of 11.5 miles and a depth of 9,147 feet. Planck W has a diameter of 12.4 miles, and its depth is 9,974 feet. Notice also in the background this heavily cratered section of the northern rim of Planck. It consists of Planck X, Hagen P, and several other undesignated craters.